Welcome to Walkabout the Galaxy, the baby quark astronomy podcast, where the science is universal, the opinions are personal, and the trivia is astro-historical.
Oh.
We are Strange, Charm, and Up, the astroquarks, also known as Josh Caldwell.
Patty Dove.
And Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. Our next episode will be recorded in front of an audience at MegaCon on Saturday, May 21st at 11 a.m. We'd love to meet you. We'll be joined there by WMFE space reporter Brendan Byrne. Check out his podcast, Are We There Yet?
Yes.
Spoiler alert.
We're not.
We ain't there yet. We are, however, at walkaboutthegalaxy.com.
Yay.
Where you can see how to order a Walkabout shirt and support STEM education at the same time. You can contact us anytime at wtg@ucf.edu. One of the three of us will answer, but probably not honorary baby quark Riley Karina, who is joining us live in the Walkabout studio for this recording. Another reason to check out this episode on YouTube.
There we go.
Featuring extra cuteness.
Extra cuteness available on this episode only. Definitely do send us an email at wtg@ucf.edu if you order a shirt so we can get it to you as soon as possible. Our Stumper today is telescopical.
Ooh. And we don't normally, none of us are telescope people, so this will be interesting.
We love telescopes.
Oh, were you?
Josh has used telescopes for observations.
Yeah.
Oh, yeah, because you look quite far out into the solar system, beyond where I'm in, beyond where I look.
So how do? You do your thing just by send something there, pick up a rock and bring it home?
Yeah, or you know,
taste it.
I can use binoculars. The moon's pretty close, so.
That's true.
Well, right, you can see it with the naked eye.
Yeah.
Okay. Well, anyway, your Stumper is EHT or JWST.
Otherwise known as Event Horizon Telescope and the James Webb Space Telescope.
Yeah. Okay. Two of your favorite telescopes.
Two of my favorite telescopes that I totally didn't have to Google today to make sure I knew what they were.
Gosh.
No, I know. So,
wow.
So I don't know a lot about them, but I really love the idea of the Event Horizon Telescope, that it's that it involves collaboration with so many different people at the same time around the world. And
it's not really a telescope, really.
It's
an
an
telescope
array
project.
It's a collaborative,
it's a linking
project
of a whole bunch of other telescopes that have their own names.
Yeah.
Yes.
That are their own independently operating telescopes.
And that's true for a bunch of the sort of new observation campaign telescopes. There's where it's conglomerations of data from different places around the world with different telescopes.
Yeah, but this one is more tightly linked than a lot of those collaborations because they have to use atomic clock timing to make sure that they're looking at the phase of the photons coming. They have that all figured out, which is mind-blowingly complicated.
And for that reason, it's my favorite.
It's your favorite.
Because I think the process that they go through is just so impressive.
Yeah.
To get those images.
Yeah, just getting how much data and the processing power they have to have now and the hard drives they
the data is so much they can't you can't email or they have to physically carry.
Can't use Dropbox.
Right.
Literally drop a box.
Yeah.
Right.
It's so old fashioned where you used to have to ship your data.
Carry stuff around.
We
That's
just
what
have
they're
to
doing.
actually do that now.
Yeah. How about you, Addie?
I'm gonna say JWST for the reasons we were just discussing, I guess. I'm super excited about the EHT results, but JWST is such a differently fantastic engineering marvel and will be amazing science. And just the images that we've started getting back of showing how it's advancing our observations is pretty amazing.
I think I would go for JWST in terms of the pictures we're going to get from it.
The pictures are sweet.
The EHT, just the fact that they are able to basically make a telescope of the diameter of the Earth.
Yeah.
Taking into account that the telescopes are looking at this black hole at the center of the galaxy at different times, and you have to worry about what's the motion of the Earth, all of that stuff to get have it act as a single telescope is really impressive. And you have to do that because you're looking at a very, very tiny thing.
Tiny
very,
thing.
very far away.
Size of a donut on the moon.
Is that oh, that's cool.
Yeah, I had seen it referred to as an orange on the moon.
Yeah, for
but
this
donut
one, they
is
did
better.
donut a lot of times on these press releases. And I like it better because A, it looks like a donut, and B, donuts.
Donuts, right.
Yeah.
But to be fair, donuts can be different sizes.
Oh, and I guess for those who don't know the story, that the EHT has been looking at the center of our galaxy.
Yes.
It is.
That story will be featured on our next
episode.
Okay, then.
Spoiler alert, there's a black hole there.
Yeah, right?
Actually, there's a giant donut.
Turns out
and it's the
Homer
same,
Simpson is there too.
and it's the same color as the one in M87.
No, it's crazy.
Oh, and Baby Quark has got one.
Yeah.
She also has a donut inspired by EHT.
Well, today we'll talk about plants on the moon, water on Mars, of course.
Again.
And tiny novae. But first, this episode of Walkabout the Galaxy is brought to you by Albedo. For a handy check on just how dark soot is and just how bright the moon is, get Albedo. This simple ratio of an object's radiosity to the irradiance on it will make you feel radiant with the knowledge of its reflectivity. Available with wavelength dependence at no extra charge, Albedo can be used in astronomy to determine the sizes of distant comets and asteroids, and climate modeling to determine the fate of the planet. From the darkest carbonaceous chondrites to the brightest snows of Enceladus, pump up your brightness with Albedo. Albedo, you press the button, we do the rest.
You press the button, we do the rest.
Yeah.
Interesting.
What does that conjure up for you with Albedo?
Is it linked to so it's linked to some sort of brightening?
It's linked in a very roundabout way.
No.
I don't. I have no idea for this one.
Is it from like automated blinds or something?
It's automated something.
Yeah, I was like thinking like a soda machine.
It goes back to 1888 is when that slogan
You push the
came.
button.
You press the button, you do the rest, and we do the rest. And it's the first time that people could have somebody else do the rest, and it has to do with light.
Oh, is it like light switches?
Like light turning on the light?
No. It's Eastman Kodak.
Oh,
Cameras. Very cool.
The first camera, the Eastman company, George Eastman, his first camera was called the Detective or something, and he made 50 copies, and it was not a hit.
Okay.
2 years later, he made the Kodak, and in 1888, and it was the first time that there was a camera that you didn't have to develop the film.
Okay.
You'd take your 12 pictures, and then you would mail the whole camera to the Eastman company. They would take the film out, do all the processing, and then send you back the camera with your 12 prints and a new roll of film. So that was,
and we know it was a success because we still
exists
Kodak today.
Right? Yeah. Anyway,
That's pretty cool.
Yeah.
yeah,
I like it.
yeah.
Turns out today's sponsor message was a Stumper.
Yeah, that's right. Space news, we have the long-awaited Starliner second flight coming up.
Hopefully. Yeah.
In principle, next Thursday.
And
so the day
for Jim,
after,
who's not here, Starliner is...
Right.
Who's Starliner?
Starliner is
Boeing.
Boeing and ULA. So
Yeah.
Boeing is the... produces this. It's a human-rated space capsule,
Yep.
or about to be human-rated, we hope.
Yes, hopefully.
To take people to the International Space Station. So it's the Boeing ULA version of the Crew Dragon
Exactly.
capsule that SpaceX has been
Or
using.
Orion. Or,
So are they? So they are. So it's all validated. And this isn't a test. This is actually. It's
I mean, it's
up
going
and
up to
It's
space.
with crew.
It's an uncrewed.
Okay,
test.
uncrewed.
Yeah,
Yes.
so they have to
Okay.
do one more uncrewed demonstration before they'll put fly crew.
right.
Yeah.
And this was supposed to happen like 2 years ago now, a year ago.
Well,
Because there was like the initial test, and then they took it out to the pad, and then took it back.
right. That was just 6 months ago
Oh, okay.
that they
What is
were out there, and they were on the pad counting down, and a few hours away from launch. They had some sticky valves,
Oh, that's right. Sticky
which
valves.
turned out to be, thanks to Florida humidity.
Also, there's these crazy stories coming out now about some of the safety culture at Boeing.
Oh, no.
And there's some report that I guess so. One of the companies that was providing the parachutes for Starliner, the like CEO or one of the people on that company was like trying to do something with installing the parachutes, and something went awry, and a pin popped, and something burst, and like he fell off a ladder, and something fell on him, and he like had to have his lower leg amputated later because like of the way the surgeries had progressed.
Oh.
That might cause a delay.
So that was like there's maybe not been great safety
I might
culture.
edit that whole story out of this podcast.
That's fine. But there's been all sorts of interesting delays to that have to do with early software stuff.
Yeah.
Then there was just like the whole processing was a little bit. So it's been interesting. But hopefully
They've got their things in order. Yep.
They get their valves unstuck.
Right. So that's coming up. Speaking of JWST, or as Hannah likes to say,
JWST.
JWST.
I'm okay with that.
I want the vowel sound in between the W and the S.
You need
to
a
have
vowel.
a vowel.
Yeah.
I want it to be something, not just the schwa, sound.
We could do JWST because it would be an E that follows.
Right. James Webb, JWST.
Yeah, let's go JWST.
JWST.
JWST sounds like they're
go
related
JWST,
to Kanye.
young
Yeah.
They're related to Kanye. It's one of his children.
JWST, right. Okay. Well, anyhow, its instruments are all good to go.
Yay.
The last instrument has reached operating temperature. This is the mid-infrared instrument, which observes out to 28 microns.
That one you have to cool down a bunch.
Get down to 7 Kelvin.
That's chilly.
That's pretty cold.
That's really, really
That's
cold.
7 away from all the cold.
That's right.
From all cold.
There's only 6 more Kelvins to go below that one. So it's very cold, and you can't get that cold even with a sun shield in space. Without active cooling. So the near infrared one that's been producing some of these dazzling pictures is just put it in the shade and you're in space far away from anything.
Easy work.
You get down to 20 or 30 Kelvin or something like that. To get down to 7 Kelvin, you have to have a refrigerator on there. So there's actually a refrigerator.
Yeah.
On
a little
the
mini
thing.
fridge. They took their own mini fridge.
Yes.
They're going to put some sodas in there.
And refrigerators, I don't know, your refrigerator, I don't know about your guys' refrigerator, but my refrigerator is noisy, and when it's on, it's shaking, and that's a bad thing so they have to be super careful about isolating the vibrations of this refrigerator.
Which is hard in space.
It is hard. Yeah.
They're all just mounted in the same thing.
Yeah.
So they're well separated, and it has 2 pistons that they had aligned so that they would sort of cancel each other out.
Like dampen that. Oh, wow.
It's crazy. People do some crazy stuff to get pictures of space.
I know. It's hard.
And speaking of crazy things, Rocket Lab did a crazy thing last couple weeks ago.
Yeah, so their new model of recovering their boosters is to catch them with a helicopter.
Mini Quark Riley Karina is very excited.
She is. It was a pretty cool demonstration. She's like, catching things with helicopters. Helicopters are dangerous by themselves, and then you're trying to catch a rocket booster with it.
It sounds like if it was in a sci-fi movie, we'd be like, come on.
Exactly.
Right.
Yeah.
Right.
Yeah. And the footage is pretty crazy, but they managed to get it. They managed to catch it, and then they didn't like the loads on the helicopter, so they did drop it. But they later recovered the booster. Like, it then landed gently enough that they recovered it.
Yeah.
I don't know if
it was all salt watery.
Yeah.
Right. I believe the plan that ULA has, United Launch Alliance, which does the booster for the Starliner that we were just talking about, their next rocket, the Vulcan, uses engines developed by Blue Origin.
The E4.
And their plan is, I believe, to recover those engines by helicopter snatching.
The engines separately from the rest of the booster?
I think so.
They're going to, jettison the engines?
I think so.
Fascinating.
Yeah.
Why?
I don't know if that's still the plan, but at some point, sometime back, I heard, obviously what SpaceX does is that they're landing the thing. And Blue Origin itself is building a new Glenn orbital rocket, and they're planning to land their whole first stage on a barge. But ULA's thing is like, and the CEO of ULA was explaining this to me, that it's just a lot cheaper to do the helicopter snatching.
I wonder as well, can you have
and that
automated helicopter,
drone
helicopters,
remote control helicopters?
Probably.
That's safer, because the idea of having a pilot just like flying towards a falling booster just is a bit out there for me.
Plus, the helicopter has to be descending, at this constant rate to match the descent
there's some
rate.
footage of it, and it it does have some parachutes, I think.
Is it like scooping the chute?
So it was like not
Yeah,
going
the
super
booster
fast
had
when they caught
was on a parachute.
Yeah.
He's snagging the parachute essentially. Anyway, very cool stuff.
Can you? There's some extra background noise.
we can pause. We can pause for Riley.
I don't know if I have a baby filter. I have various post-production noise processing filters. I don't think baby noise removal is one of them.
Baby noise removal. I wish I had that. Sometimes.
Speaking of baby noise removal, the moon.
We could have gone with speaking of cold places if we transitioned from.
I don't know.
No, yeah.
I don't know.
Okay, the moon, shall we?
Yes.
There is no sound on the moon, so that's
There is no sound. Let's record
Okay.
there. Okay, so there's been a news story that has been it's gained a lot of traction. So a lot of people may have already seen it. It's there's a group at UF that have.
I think you may not have a true lock on our. I don't know if all of our listeners are up on Nature Communications Biology's latest publications.
But it's in because I've had friends from around the world send me this link.
Really?
Being, have you seen this?
None of my friends have done that.
Oh. But they know I
But we know
kind of
these
love the
people.
moon.
I don't have any friends. That's why, though.
Oh, it's because they see moon and they go, Hannah has to know.
Right.
So yeah, it's in a lot of like your
Riley's excited about it.
your BBC News, etc., etc. So yeah, there's a team that we've grown plants in like lunar simulants before, or in various, what are they called when you just grow it in hydroponic
Yeah.
setups.
We have that going on ISS right now.
Yep, exactly. Yeah, and this team they've been approved use of a few Apollo soils to try growing plants in. Now it's not there is a reason why we haven't really done this before is because our Apollo soils are very precious.
Right.
And so. But there are actually, for those who don't know, there's actually kind of like a range of, I'd say, quality of lunar soils available. So there are those that are extremely pristine, have never been touched, are kept in a nitrogen environment, and then there are those that have been used by multiple teams, and then they get sent back when they're finished used, and they've been through many cycles.
So they've picked up various sorts of contaminations in some sense. They've been exposed to Earth's atmosphere.
Exactly, yeah.
So
they've been handled a lot.
Water and sweat and snot and things like
and
that.
or just you might get the odd piece of foil or a hair occasionally, like in a lunar sample, which sounds ridiculous, but that's kind of the world that we work in.
It's hard to keep dust clean, it turns out.
It is hard to keep dust clean, and there's actually a really interesting.
Can't dust it.
There's a really interesting sample which I wanted to mention because as I was reading the article, I recognised this number. There's a lunar sample from Apollo 17 when one of the fenders broke on the rover.
Oh yeah.
And as it was roving around, a lot of this soil got deposited onto the top of the rover, and they just bagged it up. So it was
the fender prevented these what they call rooster tails from the sort of kickback of the dust from hitting it. When the fender broke, all that stuff just sort of like made a big mess of the rover.
It made a big mess of the rover,
and
the rover traversed. Yeah, so the rover traversed along this massive route, and at the end they just scooped this soil into a bag. And
said, let's take this back too.
Yeah, they weren't sure what to do, so they said, just bag it up and bring it back. So no one's really, and no one's really used it because we don't know explicitly. It's from like a broad area rather than a specific location. So it was often thought as being less valuable, but actually it gives us like an average soil for the area.
Right.
And it was suggested it could be used for sort of space resources research. But I loved how it was described in the paper that they didn't say where this sample came from. It was just, it was a broad collection of lunar Apollo 17 soil.
At the same time, it's like Apollo's, they were a couple miles or something like that.
Yeah, it was a long trip. Well, it was but yeah, it wasn't just like a very specific pinpoint location.
But it's still like, you could say it's from Orange County, Florida.
Yeah, exactly. And it means that we can use that sort of material for experiments like this, like growing plants in and whatnot. And so this team they grew some plants in the 3 Apollo soils and a lunar simulant, so a fake moon soil that we've created here on Earth,
right?
And compared them, and the plants did grow, which is really good to see. I forget the name. It's
Arabidopsis.
It's linked to like
really commonly used. It's
linked to a lot of common foods that are
okay.
It's that kind of realm of, you can tell I'm not a biologist.
I'm not either. I was just sort of wondering, why did I ask this question? Because the answer will have no meaning to me.
There was a reason for choosing it, and that's fine.
So
also, I want to point out that the scientists who did this, one of them is a geologist, so Steve Allardo is a geologist, and he's at University of Florida. But the other two are Lisa Paul and Rob Furl, who do a lot of their plant growth experiments in microgravity. So they do a lot of ISS experiments and suborbital flights. Like we've flown our payloads at the same time for a lot of different...
Looking to see how genes are altered
Exactly,
in different launch and landing and microgravity conditions.
Right. So I'm thinking of the movie The Martian.
Yes.
So did they mix any poop in with their lunar samples to help things grow?
As far as I understand, no. I don't know if they added... did they add a nutrient mix?
They add a nutrient medium that's like commonly used, because you can't
in other words, poop.
It might have been poop.
Okay.
I think it has a clever name, but it's probably just poop.
I'm sure that, okay. And so they compared then various things from their plants. So how strong the roots were, the size of the plant canopy and things like that. And what they found is that the plants that grew in the simulated lunar soil which
is just earth rock that's been crushed up.
Right.
Yes, but carefully chosen to try and match the same minerals at least.
Yeah.
So the plants,
and sizes and shapes.
Exactly,
and all that kind of thing.
and the plants grew better in the terrestrial, that earth material, than it did in the lunar material. And then within the actual lunar soils, in the lunar soils, the soil that was more mature. So that means that it's been exposed to like the solar wind and impacts and things for longer. The plants really didn't like it that much. It's as if so the way they've described it is that the material, it has a lot of it's more reactive. Yeah. So it wants to
it wants to grab the good stuff out of the roots.
Exactly.
Right.
There's a lot of we call nanophase iron. So with all this solar wind, we separate the iron oxides in lunar soils, and you get this pure iron that is very reactive and wants to form iron oxide.
Right.
And it does that by reacting with the plants.
Out of the plant instead of letting the plant take it from the poop.
Yeah. And also the lunar soils, they're very angular, they're really jagged, and that means they've got really big, each grain has got a really wide surface area. So there's a lot of surface area for all of that reactivity to happen.
To take place, right.
So that's kind of what they were noticing, and I just thought that was really interesting.
Yeah. So, okay, so you have to, because the lunar soil isn't going to have nutrients.
Yeah.
So you got to have your nutrients. I'm not going to say the P word again because we said it enough.
Jim's not here.
Right.
Giggles.
That's right, yeah. So a lot of it is about mechanically gripping, like having roots be able to grip and grow.
Yeah, they need a
stuff
matrix to attach to.
Right, so they have to be able to wind their way around and find all those nutrients. But then also I hadn't thought about the fact that the soil itself could, and it's not that the soil is toxic to the plant, it's that it's out-competing it maybe in some sense.
Yeah, it's just reactive and it wants to react with something nearby.
Yeah.
And like some things in soils, like in Martian soil or in lunar soil, could be toxic, right? If there are, like there's like perchlorates potentially on Mars, like that kind of stuff could be toxic to plants.
Yeah.
But typically, like these are rocks that may have different levels of reactivity.
Right. Yeah, usually when you think of like poison, you think of, whatever, an actual herbicide that's, preventing the growth rather than just something like, a lot of iron.
Yeah, you're expecting some more complex chemical things going on. Yeah. So, it's good to see, and there's a lot more work to be done, but plants can be grown in
lunar soil. Provide your own
nutrient mixture.
Provide your own poop.
She said it, not us.
Yeah. Before we move out a little bit further in the cosmos, I'll drop your, as you may have been expecting, multi-part trivia on you, which is inspired by our sponsor.
Okay.
Albedo, in case you had forgotten.
Oh, I did forget, actually.
I was like, a fridge?
Right. Albedo,
Albedo.
is a precise measure of the reflectance of a surface. It's the number between 0 and 1. An object that absorbs all the radiation hitting it and doesn't reflect any of it has an albedo of 0. Something that reflects all the radiation hitting it would have an albedo of 1. So like snowy surfaces.
The moon.
The moon is intermediate.
Well,
it's not super bright.
It's decent.
It's less than 0.5.
Okay, it's not that decent. I take it back. I withdraw my comment.
It's relatively bright as planetary objects go. The really bright ones are places like Enceladus, which is covered with a very fine snow.
Yeah, like Bennu and Ryugu are real dark.
And then asteroids tend to be very dark, less than 5% or less. Yeah, really dark. So anyway, that's what albedo is, in case you didn't pick it up from the sponsor message. Albedo comes from a Latin word.
Okay.
What does that Latin word mean? Here, it's multiple choice.
Okay, great.
Your choices are reflection, mirror, whiteness, darkness, brightness.
Okay.
All right. One of those 5 words translated into Latin gives you the word albedo. The second part is also multiple choice, and that is who introduced the term albedo. Obviously, it's just this Latin word that had been used. Riley, stop beeping.
Just dinged.
Obviously, it's a Latin word, so it's been used in whoever was speaking Latin. But who introduced the term in this physical as a physical quantity that we use to describe reflectance? Was it Galileo, Newton, Halley, Lambert, Fresnel, or Huygens?
Optics people, that makes sense. Oh, okay.
All right. So those are your choices. Anyway, we'll come back to that after we've worked our way further out in our Walkabout the Galaxy. Next stop, Mars.
Next stop, Mars, just slightly further out.
Hop, skip, and a jump.
Hop, skip, and a jump. And this could be relevant to growing things potentially on Mars in the past or in the future. There's new data from the, I'm going to say this wrong, Zhurong rover, so China's rover. If we recall, there was a bunch of satellite or spacecraft that went to Mars in the last few years.
They landed a year ago.
They landed a year ago.
Yeah.
And the U.S. mission, or the Chinese mission, has a rover and a lander and an orbiter.
Right.
And so this little rover has been going around taking some measurements and observations, and it's in a part of Mars where we haven't really been before that's relatively young. So the surfaces are relatively young. And it's in Utopia Planitia.
That's the good Planitia.
Which is the good place to go.
Best.
The best Planitia. I would just love to spend all time at Utopia Planitia. If I had to be in a Planitia.
It'd be the Utopia one.
Yes.
Yeah. And so this is a big open plain, basically, but there's, so it's relatively young, and they have identified some hydrated minerals, so minerals that have water in them, at the landing site. And the remarkable thing about this is it's a pretty young terrain. So it's from what's called the Amazonian, which is one of the later periods of Martian. They also have like Mars geology periods, just like we do here on Earth. And the Amazonian, I always forget the exact order, is one of the newer ones.
Less than 1 billion years old or so, right?
Yeah. And so they scooped up, they've been doing some analysis of rocks with several different instruments, so like a couple of spectrometers, and then just some like hand lens camera type things, and so they can see the albedo of the rocks. See how bright they are.
Do you happen to know who coined that term?
It doesn't say in this article,
unfortunate.
And they can look at like sort of the structure of the rocks and the albedo from the camera images, and then they have spectroscopy to look at the reflectance. And so they're also looking at the shortwave infrared. So look at the radiance, and that tells you things about water products. And so they did find some absorption features due to water, which means there's probably some sort of hydrated mineral in these rocks.
So water was there.
It was there much more recently than we would have expected. And it's in this area that looks like it's duricrust, which is like soil that's been formed over time. It's going to be like hardened, right? Because you have like water and then evaporation, and it forms this sort of like crusty, platey rocks that show up that sort of like visually you say, oh, that's probably an area there where there was water too.
like Salt Lake Flats.
Kind of,
maybe.
yeah. Where you like clearly have had evaporative processes that have left
Produces a characteristic
like flaky, crusty soil.
But still no fossilized fishes and plants.
They might have to
and-
dig down a little bit, and they don't have that on that rover. So yeah,
Otherwise, there'd be
It's hard enough
abundant
to find
fishes.
a fossil on the Earth, actually. I mean, we have a lot of them, but it took a while.
Yeah.
Yeah.
And they think that like because this is pretty widespread and because of the nature of the area they're in, that it probably all formed there. It's not like this was transported from somewhere else. And the landforms they see make it look like there was aqueous alteration.
We've had so many of these. We joke about the number of water on Mars stories that we've had over the years. Some of them have included like discussion about like water now and.
Yeah.
Also we have that with the moon too. It's like, water on the south polar region of the moon. And
Well, water ice, just like
we
to be
have to be
clear.
careful about what do we mean when we say water? Because sometimes we're just saying about water molecules that are like mixed in with rock, and that's
That's your hydrated.
hydrated minerals. The ice on the south polar region of the moon, where we say there's water ice there. Would it be recognizable to anybody if you scooped up a bucket full of that? Would you see macroscopic pieces of ice in there?
That is the $1 million or $1 billion question.
Yeah, it probably is a $1 billion question.
Because we need to know what we're pretty confident that there is water there, but we need to know in what form it is there.
Right.
Yeah.
Is it a surface frost? Is it chunky? Is it granular? Is it what? Yeah.
Yeah.
We don't know.
Like most of the signals we see from other, like, because we see water, hydrated minerals in other parts of the surface, but those are likely like, it's not going to be like liquid water or chunks of water. But there is a lot of potential that like in the South Polar regions where it's been cold for a long time, that there could be in the subsurface probably some ice. Like there's not going to be stuff right on the surface that's like physical ice, right? Because it would evaporate.
And for the moon, it's harder. There's no atmosphere and it's warmer.
Yeah.
Except in these shadowed
where it's
regions, right? Yeah. On Mars, there actually is chunky ice at the poles, at least.
There's entire ice caps.
There's entire ice caps. They're frequently covered by dry ice
There's
caps,
CO2.
but there's a permanent water ice caps there.
Mm-hmm.
And we know that underneath the surface, there's chunky ice too.
Because they literally scooped the surface and saw ice.
Right.
Yeah.
Mm-hmm. So this is really talking about liquid water flowing in rivers and lakes and things like that.
So the presence of
within the last billion years or something like that. Yeah.
Which is, I don't know. I haven't looked at my Mars water models in a while.
Okay.
I used to pay more attention to that when I did research about Mars stuff.
Okay. Well, those you could dust off.
I could, yeah. So I need to remember like what the different periods are, but that's not expected to be like it's still like a lot newer than we would expect.
Based on the evolution of the atmosphere, right?
Yeah.
We would have expected that the atmosphere is part of what keeps it warm. And, generally producing enough greenhouse effects so you can have that liquid water.
So
and Mars' atmosphere is gone.
Yeah, so you have to have maybe an impact, some sort of volcanism, something like that can create additional heat and water at this later time.
Yeah, so it may have been some transient event that made it warm for some period of time, and all the chunky water became flowing water for some time, and then it produced these deposits. Okay. Well, for our last story, we go out of the solar system to a kind of micronova, which is not something I knew about before.
Is it on tiny stars?
No, it's on white dwarfs. Well, I guess those are tiny
stars as stars go.
Right. So we more frequently talk about supernova than
we do
just plain old unmodified nova.
Bog standard nova.
Yeah. And your basic nova comes about from deposits on to a white dwarf from a binary star producing thermonuclear explosion on the surface of the star. The supernova is if it accretes enough material on the white dwarf that the white dwarf cannot sustain its weight against electron degeneracy pressure, and it collapses and blows up in a supernova.
In a very dramatic way.
One of the types of supernova. this particular discovery is about a smaller version of the nova, and it is in fact micro. It's about 1/1,000,000th as much energy as is produced in a nova.
It's still weird using the term micro for something that still
energetic.
large.
Right. So what's happening here is related to what happens in a regular nova, which is you have a white dwarf, which is the ember of a regular star. So the sun at some point in the future will be a white dwarf. Imagine that the sun had a stellar companion that was close enough to it so that the outer parts of that companion could leak on to the white dwarf, and the energy of it falling onto the surface of the white dwarf can produce basically nuclear explosions. Right? Yeah. That's a nova.
Yep.
In this case, the energy gets channeled onto the magnetic pole of the white dwarf.
Okay.
And it's a smaller amount.
It's a little aurora.
It's the process is different. The energy process is different, right? Because it is actually the reason that, one of the big questions with this is, we have emission from stuff that gets hot all the time. We don't call that a nova. Yeah. They say it's a micronova because it is still thermonuclear reactions that are producing it. Thermonuclear runaway events in, to quote the paper, a magnetically confined accretion column along the magnetic pole of the white dwarf. So you've got
interesting. So they're just
localized thing.
Jets, probably.
That's right. That's right. Okay. And it's producing, it's a runaway thermonuclear event, 1,000,000 times smaller than the one that happens when stuff is just slamming onto the surface of the white dwarf, because this is a tiny amount that's coming in, but it's confined by the magnetic field, which enables it to undergo this thermonuclear runaway event.
And it happens much, much faster on much shorter timescales than typical novae events. So they're much harder to see.
So yes. So have they imaged this? Because that would look cool.
Well, we pick up the increase in brightness, so it's photometric measurements,
there's
but not
very nice artist.
The artist's rendition. The optical brightness increases by about a factor of 3, so the micronova makes the white dwarf get 3 times brighter in less than an hour, and then it fades away over about 10 hours.
Yeah, so that's really fast. So it's hard to see. So probably why we haven't seen these before is because they're less brightness change than a nova, and also just they're going to be really transient, so you have to be pretty lucky to see them.
Right place, right time.
So they've been observed in this one particular system for some time, but it's what are we seeing?
Yeah. Okay.
You see the white dwarf get brighter, and it's not crazy brightness, right? And so the question is figuring out what is it exactly that's causing that. And now they've got 3 different white dwarf systems where they see these characteristic brightening events that they are able to identify as micronova, partly because they're able to measure the outflow speed from Doppler shift in the UV lines. They're getting escape velocity. They're getting velocities that are comparable to the escape velocity from a white dwarf.
So could this be something that regular nova do early on? Is it something that is going to prevent a nova from happening?
I don't think so. I think it's the particular configuration of the stars and where the tidal
so could we
transfer of material is.
Anticipate them and then train our telescopes in at the right.
Well, we have these 3 examples. There are 3 particular stars whose names I won't bore you with that we can look at, and see, and then, may see others that look similar and do follow-up observations to confirm that it's the same phenomena taking place. So it's kind of cool. That's a new kind of nova to add to our menagerie of nova, the supernova, of which we have 2 types.
Supernova,
then regular nova, now micronova. We need a millinova. I want something in between the micronova.
I now feel like a
supernova
supernova should be like a meganova.
Yeah, giganova.
Yeah.
Super's not super enough.
Well, super's not quantitative enough.
Oh, I see what you're saying. Right. Yeah. What's the prefix?
Yeah.
Well, I have to check that out. I don't know off the top of my head.
Yeah, we need to get the scale right.
A supernova is than a regular nova. Yeah. Okay. Good point, though. Let's find out if a supernova is a meganova or a kilonova or a teranova
Kilonova sounds.
or a giganova.
We talked about a kilonova.
We have talked about
sometime on this
kilonovas.
podcast.
We have.
Sounds
Yeah.
like
There's an episode
There's an
about
episode
kilonovas.
in which we talk about kilonovas.
Yeah.
it sounds like a really like B movie sci-fi.
Kilonova, right. Well, let's. I was going to make another terrible segue, but let's just see what you think about our astrohistorical trivia.
Oh no.
Okay,
What
ready.
albedo is a Latin word. What does that Latin word mean? Is it A, reflection, B, mirror, C, whiteness, D, darkness, or E, brightness?
So I'm going to guess whiteness because albino.
Oh, interesting.
Oh, I can't top that. I can't.
That's interesting. I don't know anything about the word albino or where it comes from.
I don't either, but I'm guessing it's a similar root
Yeah, I don't know.
without Googling it, which is what I would normally do.
I don't know.
But it's a trivia question, so I can't.
For me, I wouldn't even have thought albedo was a Latin word. I would have thought it was Arabic.
Yeah, no.
I would have thought it was Arabic for the bedo.
Oh,
Language joke.
I can't compete with that. That's too good. That's
Do
just
you
the
think
best
it's the right
answer.
buy it, though?
Do you buy it?
I do buy it.
Okay.
Really? I don't know if that's right or not because I don't know anything about albino, but it is whiteness.
Yeah. It makes so much sense.
Yeah, I failed.
Because that is
failed
like
to fool you.
albino is the root is white is because of whiteness.
And it's probably Latin.
So, and it's Latin, I think. Yeah.
Interesting. Okay.
Yeah.
So I didn't know that.
Who introduced the term albedo in this physical context? Galileo, Newton, Halley, Lambert, Fresnel, or Huygens? I didn't quite catch that, Riley.
She has a guess.
Hallie.
Hannah figures goes with an Englishman.
I was either going to say, well, I was going to say Galileo, but then you said Lambert.
Yeah, Lambert
And Lambertian
stood out.
surfaces, and but I think you're just throwing that in there because I would think that. We have to do the psychology
Is
thing.
it a double?
I put two Englishmen in there for Hannah.
I think it
In case
is-
I withdraw my answer, if he's put them in
Yeah,
there.
it's locked in. It's
I'm
locked
going to
in.
go with Lambert.
Yeah.
Sure.
It is Lambert. A double for Addie.
Genius.
Lambert was one of these people who accomplished more in his short life than I would if I had 10 lifetimes.
Yeah.
Among many other accomplishments, he is the person who proved that pi is an irrational number. He invented many map projections, including the transverse Mercator projection.
Man of many skills.
He introduced, as you mentioned, Addie, the Lambertian surface, which is a perfectly diffusely scattering surface. And he has a unit named after him, a Lambert, which is 1/pi candelas per square centimeter.
So it's a brightness thing.
I'm glad that he included pi
Also,
in it.
Miranda Lambert, I believe, is a
Distant relative.
distant relative.
Albedo, not to be confused with another Latin word, not albino. I have a dirtier mind, so I was thinking of another Latin word that sounds like albedo. Libido.
Oh, okay.
What does
Very
libido?
different train of
What
thought.
does libido translate to?
Is it also from like librating motion? Like, is it the same root? So,
No.
no.
Tell us.
Lust.
Oh, like what does it actually mean?
Yeah.
Oh, it just means like desire.
Also, well, lust I thought was a little bit more.
Sure.
Also acceptable are whimsy,
I like whimsy.
hanker,
Oh, a hankering. I got a hankering for something.
inclination, fancy, and freak.
Inclination.
I have an inclination which has its own astronomical.
Yeah.
Latin for albino
Indications.
is albus, which is white.
Okay. Well,
Albus Dumbledore.
Yeah.
Oh.
interesting. Bringing it home full circle to Harry Potter.
To England.
To everything.
And everything back to
Florida.
England and Hogwarts and Universal Studios. While it may have felt like listening to the translation of a Latin dictionary, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see Baby Quirk, Riley Karina, and how well our voices mask our visible panic. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At @walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Decatur, Georgia, and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the AstroQuarks, signing off until the next episode of Walkabout the Galaxy.
Oh, now she's quiet.
Can't get a word from her.
Like little